I'm going to review here all of the different types of probabilities that we've talked about, clear up, and including conditional probabilities to help you be prepared for that conditional probabilities mastery check. So the first thing we're going to do is just read through the problem. In a class of 51 students, 34 are female. All of the students received either an A, B, or C on their last test. 12 students received an A, and 4 of those were female. 20 students received a B, and 3 of those were male. Fill in the table below to help you solve the following probabilities, and the questions are down below. But first we need to fill in the table. So we're going to read through the question again and start filling in the table as we read. In a class of 51 students. So 51 students is going to be the total of everybody. Goes right here. In a class of 51 students, 34 are female. So female total, 34. 34 total female students. 12 students, I kind of skipped the next sentence. 12 students received an A. So A total, 12. 12 students received an A, and 4 of those were female. So we're going to put the 4 right there. 20 students received a B. So that's the total for those that received a B. And 3 of those were male. So B, male, that's 3. And then it doesn't give us any more information to help us fill out the table in the paragraph, but we can just fill it out knowing how these different numbers need to work. The males who got A's plus the females who got A's needs to add up to the total. So 12 minus 4 leaves 8 for this spot. 8 plus 4 is 12. Same thing here. These need to add up. 3 plus something equals 20. And so that is 17. We also need things to add up in this direction. So here we have 12 plus 20 plus something equals 51. So that's 19. 12 plus 20 is 32. Plus 19 is 51. So that one's good there. Same thing here. 4 plus 17 has to equal 34. So that's 13. 17 and 13 together is 30 plus the 4 gives us 34 right there. Now we have this 13 filled in. We can look at this column. So 6 plus 13 equals 19. And then our final row, our last number, there's 2 ways to figure out the last number, and I think it's a good idea to double check both just to make sure you haven't messed up somewhere. 8 plus 3 plus 6 is 17, and then with that 17 it's also part of this column, so maybe just double check, is 34 plus 17 51? And it is. And so we've got our table completely filled out. It looks good. Now we can start looking at these probabilities, and answering the questions. So I'm going to just slide this up so we can see the questions. You can't quite see all of those without me getting rid of my face, but I can do that. There we go. We also can't see our very last question on there. I'm going to zoom out just a touch more. There we go. All right. The whole thing is, oh, we can't see a little bit farther. Okay, it's all barely on there. So the first one says, find the probability that the student was male. So the student being male, we're looking at the total number of males. 17 of the people were male. And it's going to be out of everybody. Unless it has the word given, it's out of everybody. So if you do not see the word given, it will be out of everybody. So the probability that the student was male is there's 17 males out of 51 total. And that's it. You don't have to simplify or reduce or anything on your fraction. The next one says find the probability that the student was male and got a B. Both of those things have to happen. Male and got a B. Another name that we use for and is intersection. It has this symbol as well. So for that one, and is the same as intersection, that might help. If we look at the males, that's this whole row, and then we look at the bees, that's this whole column. So the intersection is where those cross, where those overlap, where those two lines intersect. That's the spot that tells me both are happening, male and got a B. This is like we're randomly selecting a person and we're wondering what are the chances that if I select a person, I happen to select a male who also got a B. And so that turns out to be 3. And again on this one, we are looking at it being out of everybody. It never said or it never said given. It never said that we already know something. So it's just going to be 3 out of everyone. 3 out of 51. Okay, the next one. Find the probability that the student was male or got an A. So this is a little bit different. Or is not the same as and a lot of times it's a little bit confusing because you kind of sometimes think or needs to be this intersection, but it's not. Or means the same thing as union, and this is the symbol for that, or together. This is we're randomly selecting someone, and if it happens to be a male, I'm happy. And if it happens to be someone who got an A, I'm happy. I'm happy either way. If it happens to be both, that's fine too. I don't really care if it's both. I'm happy with one or the other or both. That's what or means when we're looking at probability. So if they were male, again, that's this row, or they got an A, getting an A would be this column. We're happy as long as they're in any of those boxes that have that red shading on them. But we don't want to count these 8 twice. You can see they got shaded twice in red. And so we've got a couple different options when we're doing this one. One option is to just add up those boxes that are shaded in red. 8 plus 3 plus 6 plus 4, which is 21. And again, like all the ones we've done so far, it hasn't given us any already we know stuff information, no given information, so it is out of 51. So we're at 21 out of 51. The other option is to just look at the totals for each of those. We had 17 total males, and we had 12 total A's. So that's 29 people. You can see that's not the same answer. And it's not, and it won't be, because we don't want to count these 8 twice. And if we add these totals, we do count those 8 twice. So then you do have to subtract the 8, so they're not counted twice, so they're only counted once. And you can get the 21 that way as well. Either way works fine, but just remember, it's still out of everybody, and we want to count these ones, but we don't want to count anything twice. So our last question is where the conditional probability comes in. It tells us given right here. Given, remember, sometimes the symbol that is used for given is just a straight up and down vertical bar. So if you see that straight up and down vertical bar, you know that that is given. And so we want to know female, given they got a B. Whenever we're given something, given they got a B, we only want to look at that thing. We are only looking at the people who got a B. We're not looking anywhere else, only in that box. We were given that. We can pretend that the whole rest of this doesn't even exist. We just want to look at this section of the chart. We do have to look at these names over here, but other than that, we're not looking anywhere else. We know they got a B. If we know they got a B, it's out of 20. 20 is the total that got a B. So it's going to be out of 20. We're not looking at the 51 anymore because it said given. We already know some extra information. The extra information is that we know it's in this section right here. We know it's out of these 20. So we're out of 20. Now we just need to find the other part, that the student was female given they got a B. So now we're going to look at female. We're only going to look in that pink shaded section. 17 females got a B out of the 20 total people who got a B. So that one is 17 out of 20. So hopefully that little review can help you remember how to do probabilities, including conditional probability.